Hello everyone, this is a video for Calculus 1. We're going to be talking about the chain rule steps, specifically what steps we need to do and how to recognize that. Now we use the chain rule when we have two functions kind of packed together. We have what's often called an outer function, which is this f of x, and then we have this inner function, which is our g of x. So this is our inner function and our outer function. And what we do to get the derivative of this is we take the derivative of the outside first, keeping the inside the same. And then we multiply by the derivative of the inner function. And there are a lot of different ways to do this, but knowing this can help us save some steps and make our life a little bit easier. For example, if we have to take the derivative of 1 over x squared plus 4x, right? That we do the quotient rule, and there's a lot of steps where we can make mistakes with the quotient rule. But what if we rewrite it as x squared plus 4x all to the negative 1? It's the same thing, right? So, and this is our outer function, the parentheses all to the negative 1. Our inner function is our x squared plus 4x. So what we do is we take the derivative of the outside function, we use the power rule, bring the negative 1 down, and subtract 1. That gives us negative 1 times x squared plus 4x, and negative 1 minus 1 is negative 2. Then we multiply by the derivative of the inner function. The derivative of x squared is 2x, plus the derivative of 4x, which is 4. We clean everything up. This negative 1 stays. 2x plus 4 has the positive exponent. And then x squared plus 4x, that quantity squared, this is our derivative with respect to x. And so knowing when we can recognize and use the chain rule, it may seem more complicated, but it can also help us to integrate things that are difficult or that we couldn't before. All right, here we've got 4 examples and we're going to have some fun. So the first one that we have is the cosine of 7x. And our cosine is our outside function and our 7x is our inner function. So let's take the derivative of cosine, which is negative sine, and we keep the inside the same, so 7x. And the derivative of 7x is just 7, so we multiply that by 7. So our answer for this is negative 7 sine 7x. That's our first. Now for the next one, we have the natural log of the absolute value of x squared plus 6x plus 27. So the natural log is our outer function. Our inner function is going to be this x squared plus 6x plus 27. So first we take the natural log. The derivative of this is just 1 over whatever is in that natural log. So x squared plus 6x plus 27. That's the derivative of the outer function. Now we take the derivative of the inner function and we multiply by the derivative of x squared is 2x plus the derivative of 6x is 6, and then 27 is our constant, so it's a big 0. Writing this all together, we get 2x plus 6 all over x squared plus 6x plus 27. And that is our derivative with respect to x. Moving on, we've got this 7x squared plus cosine 4t to the 28th. Now, this actually has more than one step for the chain rule. Our outer function is this to the 28th. Then we have an inner function with the 7x and the cosine. Then we have to remember there's this another inner function kind of jam-packed in there. So if we we'll start on the outside and work our way in. We bring that 28 down and subtract 1, and that gives us 28 times 7x squared plus cosine 4t to the 27th. And so that's the first thing. That's our first outer function. The next function that we have is the derivative of the inner function. So we multiply this by 7. Oops, sorry. The derivative of 7x squared is 14x. And then the derivative of cosine of 4t is negative sine 4t. And then we multiply that again by 4 because this 4t is another inner function. The next one that we have has quite a few steps as well. So let's check that out. Our outer function is our tangent. Then inner function, we've got the cubed root of 3x, and then cotangent again over here, or plus cotangent of 5x. And when we've got this cotangent, again, we've got another inner function kind of packed in with that. So what's the derivative of tangent? It is secant squared. And we remember to keep the original inner function the same. So the cubed root of 3x, and I'm actually going to write this a little differently. It's going to be 3x to the 1/3 power. That makes it a little bit easier when working with our rational forms there, our rational exponents. So plus cotangent of 5x. Then I take the derivative of this inside function and multiply it out. Now, the derivative of 3x to the 3rd, we bring that 1/3 down and we subtract 1. So it's 1/3 times 3x, and then 1/3 minus 3/3 is to the negative 2/3. And then we've got this cotangent that we need to deal with. So we're going to continue and write it down a little lower. The derivative of cotangent is negative cosecant squared. And we've got that 5x because that's our inner function. And then we multiply this by 5. It's a little messy, so let's write it down here. We've got secant squared of 3x to the 1/3 plus cotangent 5x. Remember, that's kind of our original inner function. We multiply that by 1/3, and then 3x to the negative 2/3 minus 5 cosecant squared 5x. All right, now for some even more interesting ones. So our first example up here is a derivative kind of a law to remember. If we have b to the x, the derivative of that is b to the x times the natural log of b. So if what we're deriving is the x and the exponent, let's say we have 17 to the x and we have to take the derivative of that. That is 17 to the x times the natural log absolute value 17. And this is a property that you may not run into all that often, but it is very important to know. Now we're going to go down to this e, and in our exponent we've got x squared, it's e to the quantity x squared plus 17x minus 39. And with e to the x, the derivative is just e to the x. And so that is our outer function, this e to the x. So we rewrite that and copy it. So it's e to the x squared plus 17x minus 39. And then we multiply by, this is our inner function up here. We multiply by the derivative of this exponent up here. We've got the derivative of x squared is 2x plus the derivative of 17x, which is just 17, and 39 is a constant, so we leave it as is. Now our next example, this e x sine x. This gets tricky. Sometimes with e to the x, we don't always realize that there's a product rule going on up here. So what we're going to do is we've got that same function of e to the x is our outer function. So we rewrite that. This is e to the x sine x 4x. Now up here we've got a product rule. We have x times sine 4x. And so we multiply by the derivative of this. And the derivative of this, if we've got the product rule, the derivative of x is 1. And so we leave the second part, sine 4x alone, plus x, the derivative of sine 4x is we've got cosine 4x, but we can't forget that there's an inner function in here as well, so we multiply that times 4. So the derivative of e to the x sine 4x is e to the x sine 4x, that's our outermost function, multiplied by sine 4x plus 4x cosine 4x. Quite a doozy. Now for our last example for this video, we have secant of 79 plus 2x squared. Now the derivative of secant of x is secant x tangent x. And that's the first thing that we're going to do because our secant is our outer. So we write secant, and then the inner function stays the same. That's our x here. 79 plus 2x squared times the tangent of 79 plus 2x squared. That's our outer function. Now we multiply by the derivative of the inner. Now with this, the derivative of 79 is a constant, so we're lucky there. And the derivative of 2x squared is 4x. So I hope these examples have been helpful and that you have some fun with the chain rule.